So our theme for today is rewriting old dogma, and the first part of that I'm doing is attributes first class. I have an alternative title, which is teaching an old dogma new tricks. There's dogma. That is just the first of what will be many dog slides in this presentation. The content today will be about 50% serious technical material, 50% funny pictures of dogs. Yeah, thank you. Okay, so what is dogma? Well, I'll do the old trick of starting with dictionary definitions. So the dictionary says that dogma is a belief or set of beliefs that is accepted by the members of a group without being questioned or doubted. It actually is both a Latin and a Greek word, meaning that which one thinks is true. And the root word is the Greek dokein, meaning to seem good or to think. Thinking dogma. There's also a rather interesting Wikipedia article about dogma. And it says, dogma is a principle or set of principles laid down by an authority as incontrovertibly true. It also says, and this is a bit more relevant, it serves as part of the primary basis of an ideology or belief system, and it cannot be changed or discarded without affecting the very system's paradigm or the ideology itself. So we're going to change it. I hope you saw that one coming. That was me when I started working on this. But what is dogma in the context of Eve? Well, it's our system for managing, and by that we mean creating, updating, destroying, the attribute values for all of the items in the Eve universe. Items, of course, are just like all the things, so all the ships, the modules, the missiles, the characters, and the attributes are all the properties that those things have, such as health and speed, mass, and so on. So dogma provides a single source of truth for these values. That's assuming you don't count any of the other ones, of which there are several. We have Godma, which is the client-side mirror of dogma, because God is dog spelled backwards. Yeah. We have Catma, because you're one ahead of me, yes. Catma, because cats are a bit like dogs, only different. And that's used in Dust 514. Okay. And there was once one called Batma, which I don't want to talk about, and I am not going to talk about. So as you can see there, the central job of dogma in the Eve sense of the word is to maintain this dependency graph between the attributes of all the items in the game. So for example, your skill points attribute on your drone interfacing skill modifies the skill level attribute of that same item, so that's a loop from one item to itself, but that in turn then improves the damage modifier attribute on all your drone items, so at that point it fans out and affects lots of items, and that's when it becomes interesting. So the whole thing really is just a big computed expression graph. Representation. So naturally, the system was originally designed to represent this expression graph as, anybody want to guess? Somebody said a graph. What you did there is you fell into a trap, okay? Yes, that's right. It's represented as 10 separate multidimensional dictionaries per location. What? So it sounds crazy, but you actually can encode the graph in this way, and it's not quite as mad as it seems, but I'm not going to dwell on that. What it amounts to, though, is when an attribute changes in the current system at runtime, we have to scan through 5 of those 10 dictionaries to scan forward for all the things that that attribute might have a consequence on, okay? Having found those, for each of those, we have to scan up through the other 5 to find any of the other things that might also be influencing that attribute so that we can recalculate it. Because we have to recalculate all the influences in a correct order because of, maths. And it turns out this can be quite slow, as you've maybe experienced. Slow Dogma. Yeah, I know. He looks happy enough, though. So here's a new idea, which isn't really a new idea. It's been kicking around for a few years. I think it was CCP Veritas who first came up with this. Brian, if you're out there, hello. We're nearly finished. So the idea was, hey guys, let's represent this big graph as a graph. Some people just see things that others can't, you know? It's a kind of an insight that some people have. Now, if we do it that way, then finding the relevant forwards and backwards links between attributes becomes an immediate and fairly obvious process. You just follow the links, you look them up. And this should make things faster, especially in the currently heavy cases, so that's heavily occupied systems, big fleet fights. So we're hoping that that would be a win. And if that works, we would have clever Dogma. But actually making this happen requires elevating the attributes to first-class entities inside the system, make them proper objects, which up until now they haven't been. They're basically just pure numbers calculated on demand and then stored in a little cache. Correction, large cache. If we make them objects, though, that gives us some benefits. It might allow us to implement more complex attribute behavior, but the real benefit is that it opens the door to the long-awaited brain-in-a-box optimization. Okay. Well, okay, thank you for that. You might want to give, but this has the drawback of requiring more memory per attribute by inflating them to object scale, and that is something we have to be careful about. Now, if you look on the internet, you can actually find pictures of dogs being eaten by snakes. I'm not going to show you one because they're very upsetting. I'm just going to show you something that's almost as upsetting, and that's some Python code. Just how many of you know Python a little bit? Oh gosh, nearly all of you, okay, right. How many of you know about get size of? I think that's not so many hands. That was just a few out of the maybe 100 here. I don't think this is terribly well known because Python programmers don't care about memory. But so there is a thing built in called get size of. I don't like the name, so I abbreviate it to size, and I can use that to find out the size of various things. So does anyone want to suggest how much space it takes? Let's do it in bits for fun. How many bits does it take Python to store nothing? Nothing being numerical, 0.0. Okay, I'm hearing 64 as a suggestion, but perfectly reasonable. Not actually correct, it's 192. It takes 24 bytes to represent nothing. The reason for that, this is if you're in 64-bit Python, which we are on the server. The reason for this is that almost everything in Python has got a 16-byte overhead before you get started. That's 8 bytes for the reference count for the garbage collector, and 8 bytes for the pointer to the type or the class, because as a dynamic language, it needs to be able to know that at runtime somehow. So you get that overhead, and then at least 8 bytes of actual payload, in this case for a double precision floating point, so we're up to 24 bytes for nothing. But we don't just store numbers in the game, we also have like containers. If you know Python, you'll be familiar with a tuple. Just a little ordered collection. What do you think the size is of an empty tuple in bytes this time? What was that, 1024? Now you're just being silly. No, it's 48. But, 48 bytes to store nothing. Well, it's not ideal. And we don't always just use tuples because they're fixed, so you need a list for flexibility. If you use a list, you're up to 64 as a baseline cost. It's sometimes useful to remove duplicates and have fast lookup, in which case what you want is a set, as long as you can pay 224 bytes for one. And then sometimes you don't want a set either. You want a full-on dictionary, because Python is basically all about dictionaries. Boom, 272 bytes. So, it adds up eventually. Here's an interesting one. If you create a new class for an empty object, this is like a class, it doesn't do anything, it's got nothing in it, just sits there. What's the size of the empty object? 56. Actually not so bad, unless you include the internal member dictionary that you have to include, which adds another 272. Technically, you can get rid of this dictionary if you use a thing called slots, but I'm not going to talk about that here. So the point is, these are a lot of remarkably expensive ways in Python of storing nothing. Think about that. And it turns out the attribute graph has got a lot of nothing in it. A lot of the attributes are leaf nodes. They don't have any children, but if we have to store the list of their hypothetical, they aren't their children, we're wasting hundreds of bytes doing so. And quite a lot of the attributes are also root nodes, which is to say they have nothing influencing them. They just are initial unmodified values. So we're wasting space storing the nothing for that too. And that leads to this. So how can you store nothing efficiently? So we want to store nothing efficiently. So we want to store nothing efficiently as opposed to storing nothing efficiently. It's an important distinction. I've improved the grammar on the slide to make that clearer. So the trick is use none. There's a special none value in Python. It represents the idea of emptiness or non-applicability. And if you use that, its size, well, if you actually ask for the size, it'll say 16. But here's a trick. There's only one none in the whole system, and everyone shares it. So the effective cost of using none is 0. Okay? So with that one simple trick, I was able to reduce the additional memory overhead of the new system by a factor of 4. But it wasn't just as easy as that. There are some other things we had to do to get first-class objects. There are tens of thousands of lines of code that we had to kind of go through and make sure we had, modified appropriately. And that code is just as well documented and unit tested as you would expect for a, hastily developed, heavily revised, 10-year-old, multi-authored piece of legacy code. Not very. So we had to be very careful, and it took a bit of time. There are also lots of special cases in this code. That's just the way it is. They've grown up as the game has grown up. For example, charged attributes. Those are the things that deal with your shield and capacitor. They sort of change on their own in ways that are a bit special, so they are a special case. Heat attributes are a special case. The stacking nerfs, oh God, are they a special case? There are change callbacks on some things. They're a special case. There are fleet bonuses. My God, fleet bonuses. In fact, fleet bonuses. There's a diagram of a fleet. Obviously, I've simplified it because I didn't want the diagram to become complicated. So you can see at the top there that there's a fleet cell, and that's got a number of, in the real game, up to 5 wing cells underneath it, and each wing has got up to 5 squads, and the squads have got people, and the people have got ships. But this, of course, is, as I say, a simplification because you might have a booster on one of these wings. If you don't know what is a booster is actually a person who has the ability to confer bonuses on the wing. By default, that would be the wing commander, who is really the only direct member of the wing, but it doesn't have to be him. It could be some other guy, maybe that dude down there, acting as a booster. And if that's the case, and if he's got the right kind of fleet boosting skills, and if the wing commander has got the right kind of leadership skills, this will lead to the creation of a fleet bonus attribute, which will get propagated through like that. And then that will make the wing commander have some bonus, which is fine, but it's not all we need. We need this to propagate down the tree. So we also need to have a fleet bonus attribute at the squad level and have that one talk to that one, like so. But of course, this is a bit of a simplification. You obviously have to have then the fan out from the squad level thing to not the members, but the ships. So it works a bit like that. Of course, that's not the full story because you might also have a booster at the squad level. And if you do, then who might be that guy? Then he would have an effect over here. And the net result is the maxima of any of these influences, which then gets propagated. So that's how that works. Obviously, I'm simplifying it a bit because I didn't want the diagram to become complicated. In reality, there can be more than one fleet bonus attribute, like that. In fact, there can be up to 4, in fact, theoretically more than 4, so that creates its own difficulties. But as I say, I'm simplifying it because I didn't want the diagram to be complicated. Of course, there might be a booster on the wing there and the squad there, and if that was happening, you'd need to do something like this. That, of course, is a simplification because the wing bonus would have to propagate to all 3 of the squads below it, not just 1. So it'd be like that. And obviously, this is a simplification because there might be a fleet level booster, and if you had one of those, it would be a bit like that. I should perhaps point out, I was drunk when I wrote this slide. And I'd like to thank Berglund for that. She gave me the champagne. Goodbye, Berglund, we miss you. Okay, so as you can see, fleet bonuses are special. He's lovely though, isn't he? But he wears the cone of shame. But there is some good news in all this. The good news is we're getting there. Earn our own sandbox. We have this stuff running right now. And we've just put it into regression testing this week. So there are people working away on this to check that it's all as it should be, which is important because we don't want to break things. And also our local tests show that combining this with Brain in a Box, system jumps are now over twice as fast. Now, I must tell you, this is just current testing internally, but we're relatively confident in this. Of course, we need to do more work to get this, first of all, through regression test, then a mass test, some internal bot tests to ramp this up, make sure these benefits continue. But we're relatively optimistic, but I'm not writing this in my blood or anything. Okay, so with any luck, if we do this, we'll end up with good dogma. That's me on the left. This is quite an old picture. This is about 7 years old now. So yeah, I was younger then and thinner, and I still had all my own hair. And on the right, in the foreground, we have Leica, and in the background, Flash. So happy dogma. Possibly even inspirational dogma. There's Flash again. At this point, I'm afraid I have to tell you, Flash sadly died last year, so I put in these slides as a little tribute to her, and to her interesting philosophy of life, which is as follows. Don't be trapped by dogma, which is living with the results of other people's thinking. Don't let the noise of others' opinions drown out your own inner voice. Surprise twist, these are not the words of Flash the dog. These are actually the words of a guy called Steve Jobs. Do we have any Steve Jobs fans in the audience? Well, a couple, okay. So at this point, I have to alienate those people by saying that I'm not actually a big fan of Steve Jobs, for reasons I probably shouldn't go into. But I am a fan of some of the many talented people who he, by his own admission and in his own words, shamelessly stole his ideas from. One of those is a guy called Alan Kay. How many of you know who Alan Kay is? Yeah, we're getting like maybe a handful. You should read up on Alan Kay. He's a great guy. But anyway, he had this to say about dogma. Science absolutely can't allow dogma. You have to allow scientists to think and explore and come up with any theory. And then, for it to work, you need the second level, which says, okay, now let's debug these ideas. And that's what we'll all be going back to do on Monday. Thank you.
Thank you, Pat. And thank you all for being here. Am I on? Yes, I am. Okay, so I am going to talk about Brain in a Box. And first, I want to see a show of hands. Is there people here who don't know what Brain in a Box actually is? Very few of you. Well, that is because we talked about it last Fanfest. This is from, this is first introduced in Fanfest 2012. And last year we talked about it and said things had happened. So that's not a lot, but I'm going to talk about a bit what's been happening since then. You might also have seen it this is what, 2011, I think? No, this is 2012. And first internally, I found a mail, well, CCP Master Plan found a mail from 2011. So it's been a really long story. This is for the CSM. And this is what, I'm going to explain what Brain in a Box is actually trying to do. So this is how things are as they stand. You have a location node X and a location node Y. this brilliant spaceship here that wants to cross between that dashed line barrier there. These could be logical nodes, these could be physical nodes. But to actually move you from location JITA to whatever system is next to there, a couple of things have to happen. So first of all, we got to remove you from this side and do some cleanup there. And then we got to build your entire ship again on the other side, starting from your skill point instances in your skills and applying them to the basic level, blueprint of your ship. So just to show you how annoying this is again, this is a scientific animation. It takes a lot of time, an annoying amount of time, and that's why this takes an annoying amount of time. So what's actually happening there is something that Pat actually touched on. If we just look at your Hobgoblin 2, you have a damage modifier attribute on it, and it is 5.28. But it's 5.28 because you have skills. The actual type value is only 1.92, and you have skill levels that give you a value of 100% from the drone interfacing skill, 25% extra, and then 10% extra respectively. And you can see the calculation down here. It adds up to the type value of 1.92 times 2.75, but that's not the calculations we have to go through. We actually have to take the default skill level, and the default skill level of any skill is 0. So because you have level 5 there, you get this multiplication of 5 times 20, giving you 100%, and then over there. But that's not all, because the default skill level is not 5 on all skills, it's actually 0. So that's why the 0 times 20% is 0. You don't get any bonus unless you actually have the skill level trained. And to get the skill level, we need to actually look at the skill rank and the skill points and do some calculations, and then we get the skill level, which we calculate with the other stuff. And it's just a lot of calculations that we have to happen. Now, if then your fleet booster jumps into the system, then he adds another modifier to this, and because we only store the end value down here, we actually have to do the calculations all over again. Now, if he's not your actual booster, but just the booster that's the booster now, and then the actual booster jumps in because he's got a better bonus, then we do the calculations again. This is not very efficient, and we'd very much like it to be. So, we have this concept of character nodes already. They don't do much for us right now, they just store information about your character, but it's just nice to have this one glorified database node to talk to when we ask information about your character instead of talking to the database. So, what we want to happen is, when your scientifically accurate ship comes in there and wants to jump over, well, we're still going to do the cleanup on this side. But instead of spending all this time building up your skills again, we just grab the brain from the character node and throw it on there, and you see this took less time than the last animation, and therefore you know it works. So, efficiently speaking, we're just doing what any school child would do. I mean, you just factor it all together here into this 2.75, and you save that, and you keep applying that over and over again, rather than going through all the calculations over and over again. See? So much easier. What's it again? One animation. So, the story behind this. Well, like I said, this CCP master plan dug up this email of the first mention in 2011, and we were talking about this Fanfest 2012, and again 2014, because there was no Gridlock in 2013. But in July, after Fanfest, we just made a brain in a box sandbox that's just forking the branch and starting work. A week later, we had the prototype and knew it worked. We couldn't jump though, which isn't really great, but we knew it worked. 2 days later, we could jump. That's not a lot of work right there. And I was just quite happy, so I just went on summer vacation. And I was honestly quite optimistic at that point, and just thought we were going to ship it in September and like gold-plated Ferraris for everybody, and we all know that didn't happen. So, when I came back from vacation, we took a little stock of what had happened. Where were we at? Well, we as Patrick explained to you, attributes were now their own masters and no longer had to be tied to items. That's great, and we can do it right in the box. So skill effect work had now been offloaded to his location nodes, and we no longer had to build up the skill tree of skill graph of every pilot that jumps into JITA, and there's a lot of jumps into JITA. The same goes for all fleet fights. And this has all been offloaded to a single centralized authority. And that's good because then we don't have, all the location nodes were just doing the work before, just any location node. Now we can just ask this one node, hey, give me my skills. Have they changed? No, they haven't. Well, okay. This is great. Then you start thinking about the other things, because we know that nothing has actually gone out. So why hasn't it? Well, as Patrick explained, attributes always had to be associated with items, because Dogma always worked with items, and Dogma is the first is what processes your skills. So it stands to reason that skills must be items. And we've put a lot of work into divorcing attributes from items. But skills are still items, and they are handled in the node they are located in, because that makes sense. And they are located inside your character, because when you inject a skill book, that's exactly what you're doing. You're injecting a skill book into your brain. The location of the skill book now becomes your character ID. So we are offloading work from the node that the character is in, but the work is still actually in the, like the inventory is still all in the character, and oh dang. So this is where we found ourselves, and you know, it doesn't really look great there on this railway track, but I really don't want to go into the tunnel, but oh my god, I had to go into the tunnel. And this is when my Twitter feed takes a turn to the sinister side. And at some point I just gave up and decided to start rewriting stuff instead of refactoring it. This is actually really important. We'll kind of get to this later, but it's not self.self pointer equals self. It's a bit more complex, but there are really good reasons for it, and I had no idea about them. And then we go on, you know. It's I'm just getting really, really rude at this point, and yeah, this is like this is my own pain, bringing my own pain onto myself. But and yeah, I quit smoking. I honestly quit smoking while I was working on this, because you know it was just easy at this point. Thank you, thank you. Now, so we had to divorce inventories and the inventory system and skills, and you know, it was just necessary drudgery work. There was not much to gain from this, at least not facing you. I mean, if you were in Tuxford's talk yesterday about legacy code, you'll know that these lines of codes are not a really good metric. I didn't actually get the cyclomatic complexity, but I can promise you that these two files here have a lot more profanity than these two files here, because I'm losing my mind here. So there's also, the gains are quite a lot of weird defects have been solved with the skill queue, because the skills were in your head and you jump between systems, we gotta move the skill queue processing from that system to your new system, because it's all in your head. You jump through a start gate, we pack up your skill queue, we launch it through a start gate. This is not technical talk, of course, but you know, it's just these weird situations you find yourself in because Dogma had to handle items. And there was a lot of pain involved in this, and I just really, like, I'm getting sad, so I don't want to go into it. Whatever. And we go back to work. And remember how quickly all the brain in the box work took? Well, I messed up. I didn't fork out the sandbox there, so you know, I ended up submitting 150 files in one change list, and that's never a good idea. So in October, I started working on the skill training. That takes a month of just, you know, this is just handling the accounting of where your skills are at in the database and everywhere else. That's a month. December, I'm still working on it. That's 2 months. January, okay, I'm finally starting working on something else. February, I mean, you can see where I'm going with this. Like, all my work has been going into rewriting skill management. And then we found a massive architectural problem. And then we fixed it in 2 days in Brain in a Box. Because Brain in a Box is just easy. It's the skill rewrite that takes a lot of pain. That was all of the pain. And just so I can maybe help you guys somewhat, if you ever find yourself in this situation, make a branch of the code. Then you can at least, you know, leave that code and just go working in the other branch and just, you know, get some, you know, ego back up, because constantly doing mistakes is not good for your ego. If your ego is shattered, you're not going to do good jobs. Then you do stuff like, you know, from 115 file change this because you're just, oh god damn it, just put it in there, just work. And to be fair, I'm a database developer here, if you remember me, but I always knew that skills were items. I just didn't want to think about it. And if I had, I might have actually done a better job and created an interface in the main line before I actually started work in our sandbox, because then I could have made that interface take a lot of integrating pain away from me, but I didn't. But that's okay, because we're getting there, like Pat said, and we do have gains, and we know we have gains, but we still have stuff to do. And it might have been a painful way to get here, but there is this fancy bench there, and we'll get to that fancy bench quite soon, and then there's more work to be done. But yeah, that is pretty much it. So now we're going to move over to a Q&A session, if we have time still, which we do. Guys, you want to come up here?
switched your mic off as well? Yeah. Okay. I think you said there was a switch at the bottom.
Yeah, I did switch it. Testing.
Oh, okay, we have it now.
There we go. Okay. Okay, so maybe just start off by introducing ourselves again.
Yeah, I'm CCP. Is it on? Yeah, I'm CCP Habakuk, working as QA for Team Gridlock and on this Brain in a Box and Dogma rework.
And I'm still CCP PrismX.
And I'm still CCP Hedgehog, stroke Pat.
So let's go. Just raise your hand, and Dan here will jump to you.
So you said that you're going to store these attributes separately on a different thing, which is going to load, and it's just going to have the values there. How often does it recalculate there? Because
it never has to unless you finish skill training. Currently, we're just recalculating everything on that, but we don't really have to. But as we're actually trying to push stuff out and finish it rather than like optimize the smallest portions of it.
So it doesn't kind of know about things outside of your skills, like
well, we're only pre-cooking that part.
Okay.
We're in the nice situation where skills the math behind it allow us to do it like that. Of course, if it didn't, then we would just mess everything up. Boom, boom.
Hi. You on your nice diagram there, you were creating a player node. And so the player information was stored on there, and then the ship was there anything. Could you create a ship node and then just change the location of that node rather than having to actually delete it from one place? And would that work?
So sure, we could.
Because that saves you having to, if all the information, like, you know, how much stuff you've got in the ship and whatever is stored on the ship node, then that way when the ship jumps in, you're not having to transfer all that information from one node to another.
So we could, you're saying we should have a specific node, you know, a unique node per ship ID, which would do all the calculations for that ship, and then the simulation node would just query the information to that node back to itself.
Yeah.
Yes, exactly. Like I have talked about this with Nullabor when we were discussing new service configuration and architecture cluster configuration for the game. We currently don't have a very good not network layer, but ICP or RCP, our processes for that. There's kind of a built-in latency that really doesn't have to be there, but it kind of has to be there. Don't ask me to explain this, it just has to be there. So if we fix that, that would be a really good idea, I think. At least something to look at. But currently we can't really look at that because it would be a bad idea, I think.
But yeah,
thanks.
At the moment, the simulation and the ship attributes are too closely coupled, so that we would need too much real-time communication between them that it does not really make sense at the moment.
But it's something that we are definitely looking at in the future, far future. No promises, ever. GM.
Hello. In your presentation, you spoke of location nodes and character nodes. Approximately how many of these kinds of nodes total are there on the Tranquility cluster on average?
So these are not recent numbers. I know they are wrong. The numbers that I'm familiar with is we have 248 physical nodes on Tranquility. Of them are, I think, 10 character nodes right now, but we will have to increase it when this happens because currently they're just repositories for data. Then we split them up into Empire Space and NullSec, and I think there's probably around 200 nodes for all the location nodes. Most of our nodes go into locations, and the other ones go into the few other services, and then character nodes and market nodes. Does that answer your question?
Yes.
Yeah, hi. I feel like when we form fleet, we're spending a lot of time checking that the fleet boosts aren't bugged. Is that something that's going to go away when you do these rewrites?
I certainly hope so. That has been a difficult area. You can perhaps understand why. I think the structure of the new code, for all its Byzantine complexity, has a certain coherence to it, and I think the propagation should be more consistent. I'm certainly hoping that we can do some more testing on that before we come out. I know that in the current system, depending on the order in which things get applied, you might end up with a misconfigured fleet and you have to kind of go out and come back in again.
Yeah, we're doing a lot of stuff like we don't set free move right away so that people don't get moved into the wrong slot in the wrong order.
Yeah, so my hope is we can fix that, because those things are bugs, but they're artifacts of how just complex it all was. The way it is now, I mean, what we have to do is sort of the same, because the rules are the same, but I think the structure we have now is a bit more intelligible, and I'm hoping that we can get good consistency there.
I think a lot of people would appreciate that.
We'll try to do it then.
Very important for this will then also be public testing, including mass testing, etc., where we invite all of you to help with this a bit.
Please help with that, because I rewrote skills. If you lose your skills on Tranquility, nobody's going to be happy. So come on, CC, tell me if it's gone.
I have 2 questions. Number 1, what if I'm a fleet booster and my skill training for whatever skill that is my fleet boost 5 completes while I'm in the middle of a big fleet?
Let's make it more complicated. You're actually in the middle of transit through stargates as well. So we're packing up your fleet information and your skill. No, not your skill information, but your.
Enough.
Well, your skill queue, yeah, and weird things. I don't trust myself to speak for what's going on.
I think we have
Tranquility
currently
right now.
a defect about exactly this issue. I'm not sure if it's completely fixed or not.
Yes,
but
that's in progress.
It is work in progress.
And so then my second question is for CCP Habakuk. What do your regression tests look like? Because if you've found and fixed a bunch of bugs in the new code that are in the old code still, you're going to have now you have no truth. Because the old one was false, but the new one is different. So what are you doing?
Regarding behavior, it should behave the same, at least from a regression test point of view. There are some very minor changes, but currently we are using the old regression tests for the old system and make sure that this still applies. And I think for the whole test scripts, we might need to rewrite just for the changes 2 test cases or whatever. On the other hand, we will also need to improve our regression suite for this quite a bit, add more test cases, etc., etc. But there are nearly no real feature changes.
Is it all running on stackless Python?
Yes,
Yeah.
that's we haven't changed anything there.
Just a quick joke. All fleet boosters are asked to please refrain from jumping through stargates while a related skill is about to be completed in the next 20 seconds, or else Tranquility will die. Thank you.
That would make things easier.
So
could've,
knowing
not
that you
done
can't
this.
commit to a time frame, but at the same time knowing that some parts of this are 4 years old, do you have a hopeful time that you're willing to be finished?
Like the idea is 4 years old. Oh, I am pressing something that turns off my mic. I see, that's clever. Sorry, the idea itself is 4 years old.
Yeah, the actual work has really only been committed to seriously over the past year, and with the team is now just us. We're just trying to get it finished. So, but we, yes, as you know, we can't commit to timelines. We've been talking about that amongst ourselves, and we would like to say kind of late summer is the window we're thinking about now. But that's subject to it not showing too many problems in the regression test, that it scales okay. I mean, we're fairly optimistic about that, but we need to go through those steps. And then if we do, we need to find like a launch slot. That's perhaps easier to do now than it was in the past, but because it's such a big change, we really don't want to go out on top of anything else big, just in case. So we need to just find an otherwise kind of relatively quiet window and get it out. So we're definitely working towards that as quickly as we can.
And for public testing, mass tests, etc., within the next 1 to 2 months, I think we can have the first public tests.
So how good are third-party tools like EFT in reproducing the numbers that you see like in-game? Like, I've always wondered, because it just seems like they're reverse engineering this entire system. Have you Have you looked at them?
I have not. Have any of you?
As far as I know, they are pretty good. There are some minor differences from reverse engineering because we have, but I think nearly everything is at least very close to the real implementation.
I noticed from being on IRC that there are people that just use the static data export we have and have been asking for extra Dogma data in there that I thought was completely useless for them because there was no way they could use it for anything, but apparently they could because they understood the system better than I did at that point.
So I see we just have a couple of minutes left. We can maybe take one more, but I think it might be worth finishing so people can get to the 5 o'clock presentation if they want to be there. Is there anything else? I don't see it. So in that case, I think we'll just stop it there. Thanks for coming.